part 2 is going to continue to use our special right triangles and our SOHCAHTOA properties. So if I look at this example, what kind of a triangle is triangle HJK? Well, if I notice here and here, these are the same, these are the same, this means it's a 45, 45, 90 triangle. So the measure of angle J is 45 degrees, and then it's going to ask me the tangent of J, and if I go to my table, the tangent of 45 degrees is 1. And if I look at it here, here's a J, tangent is opposite over adjacent, tangent of J is 5 over 5, which is 1. So you see that our table and using actual values are going to work. If I look at this problem, what is the sine of C? This is creating a situation. Here's C, sine, opposite, over hypotenuse. So the sine of C is 12 over 24. We always reduce, so the sine of C is 1/2. Now we've already talked a little bit about this table. It's something you're going to want to look at. Make sure you know how to read it. These pictures here are showing you where the numbers come from. So if I have a 45, 45, 90 triangle, here's my theta. And if you think about the opposite over the hypotenuse, the sine of theta is 1 over the square root of 2. Well, we can't leave a radical in the denominator, so we're going to multiply square root of 2 over square root of 2, and we get the square root of 2 over 2. And you see the sine of a 45 is this. And you see that the cosine is the same because the legs are the same. So you could go through and derive all of these angles from this table from these special 30, 60, 90 and 45, 45, 90 triangles with their very specific measurements. Now, the inverse trig ratios. Sometimes we want the angle. So inverse trig is when you want the angle measure. So what we're going to do is we're going to undo the ratio. So we're going to find the ratio, and then we're going to use our calculators to figure out what angle produced that relationship. So we want to find the measure of angle E. So let's just start there. So here is E. Based on what I'm given, what trig ratio can I set up? Well, I know hypotenuse in relation to E. 12 is the adjacent. So if I have adjacent and hypotenuse, I have the cosine of E would be equal to 12 over 13. Now this is the trig ratio, but if I want the measure, we need to go to our calculators, and on your calculator you're going to have a button that says cosine, and right above it you're going to have cosine minus 1. Now that's not really a -1 exponent, and it's not a negative value. It's a notation that basically says undo the cosine ratio. So what we're going to do, and I have an online calculator, is I'm going to hit the second button, and you see how all of these turned to those -1 values from their regular sine, cosine, tangent values. So I'm going to hit second cosine, whoops, clear. I'm going to put, for this calculator, my angles of, what was my problem? 12 over 13, 12 divided by 13, and then I'm going to say second cosine. You have to know how to use the calculator. Clear. Parenthesis 12 divided by 13, second cosine yeah, 12 divided by 13 second cosine. It is a 22.6 degree angle. Okay, play with your calculator to make sure you know how to use it because clearly that is important. 22.6 degree angle. Now, I could use the triangle 180 sum with 90 and 22.6 and f to find f. I like to use that as my check. Instead, I'm going to use my calculator with a trig ratio with f. So in relation to the f, I know the opposite in the hypotenuse. So I know the sine of f is equal to 12 over 13. And so if I go to my calculator, and I say clear, and I say 12 divided by 13 equals, and I hit my inverse sine, I get a 67.4 degree angle. And then I can say, check, does 22.6 plus 67.4 plus 90, does that equal 180? Now you have to allow for a little bit of rounding error, but within a bit, you should come out at 180. So you need to be very careful with your directions whenever you're asked to find angle measure or ratio, what exactly it is you're finding. So J, in relation to J, I know hypotenuse and I know opposite. So the sine of J is equal to 9 over 11. And if you go to your calculator and you do 9 over 11, clear, 9 divided by 11, and you do inverse of sine, you get a 55 degree angle. If I want to find K, in relation to K, I have the adjacent and the hypotenuse, so I have the cosine of K is 9 over 11, and from my calculator, I do 9 divided by 11, inverse cosine, I get 35 degrees, and that works out perfectly. So these next examples are just asking you to go to your calculator and say, find the measure of G if I give you this. So you go to your calculator, and you say 0.53, and it's the cosine, so I use the inverse. It's a 58 degree angle. The tangent of 2.25, so clear, and I put, clear, 2.25, inverse tangent, it's a 66 degree angle. And the sine of 0.978, 0.978 inverse sine, I have a 78 degree angle. Now, a little note here, cosine and sine values are always less than 1. If not, you will get an error. Tangent values can be greater than 1, so just keep that in mind. Our last example for this section, last two examples, are ladder problems again, very common in trig. So I have my building and my ground. So I have a 5-meter long ladder leaning against a building. The top of the ladder is 4 meters above the ground. What is the approximate angle that the ladder makes with the ground? And so if we start with, what do we know in relationship to this? We have the opposite and the hypotenuse, and so we're talking about the sine of an angle is 4 over 5. And if we go to our calculators and we do sine inverse of 4 over 5, we find out that this is a 53.1 degree angle. If we have a 12-meter ladder leaning against a building, it rests on a point 10 meters above the ground. Find the angle the ladder makes. So a very similar type of problem. In relation to this angle, I know the opposite and the hypotenuse, so I'm still talking about the sine of theta being 10 over 12, which would reduce to 5/6 if you want. But I go to my calculator and I use that inverse feature of 5/6, and I end up with a 56.4 degree angle. Go ahead and try the check problems, and good luck with your homework.